All right, everyone. Good afternoon. Thank you for being here. If I could have your attention for just a moment, I'll quickly introduce Jim and get us on our way. Welcome to the Education Policy Seminar today. My name is Preston McGuirk, and I'm a graduate student in the Ed Policy program here at Curry. This talk is part of the Education Policy Seminar series sponsored by the Bankard Fund for Political Economy. Each semester, Ed Policy Works hosts a number of speakers to provide talks on various education policy and research-related topics in a public setting. Our next speaker will be Tom Kane from Harvard University on Thursday, February the 20th. For more information on that talk and on each of Ed Policy Works seminar series talks throughout the semester, you can reference our website. Today, we are here to listen to Jim Soland. Jim is an assistant professor of quantitative methods here at the University of Virginia and an affiliated research fellow at the Northwest Evaluation Association, an assessment nonprofit. His research is situated at the intersection of measurement and policy and has been featured by the Collaborative for Academic, Social, and Emotional Learning, as well as the Brookings Institute. Jim brings to this work a perspective that has been shaped by previous experiences as a classroom teacher, a policy analyst at the Rand Corporation, and a senior fiscal analyst at the Legislative Analyst's Office in California. Jim will be talking for approximately 1 hour, and then he will leave 15 to 30 minutes for discussion and questions from you. Please note that any additional or personalized questions after about 1:30 p.m. should be addressed via email to Jim. I can note from emails to Jim in the past, he's very responsive, so feel free to send those, I guess. As other meetings for Jim will begin at that time. Thank you for attending today's Education Policy Seminar, and please join me in formally welcoming Jim Soland.
Well, thanks so much for having me here to do this talk, and it's nice to look around the room and see a lot of familiar faces. So I've met a lot of you in my first semester here, and looking forward to getting to know all of you a bit more. So I'm going to talk about kind of a broad swath of some of the research that I've been doing, and I have a couple of goals with all of this. One is to hopefully show you something that's relevant to your work, whether it's policy or psychology or wherever you're coming from, and provide opportunities maybe to think about ways we can collaborate and work together going forward. The other is to just make the case more broadly for why measurement really matters in a lot of the work that we do, and to think about it in the way that I think about it. And so those are the two things I'm going to focus on in this talk. And what I'm going to focus on in particular is thinking about if we care about growth, if we want to estimate the growth of a student, whether that's a gain between 2 time points or a value-added estimate or a growth model for developmental psychology, a lot of these measurement questions that sort of seem secondary really matter quite a lot. So I'll launch into it. Here's a little roadmap for what we'll do. And I should say, please, we've got the time reserved at the end for questions, but absolutely interrupt as we go. I'd rather have this be conversational. But so I'll start with a little background section that I'm calling "What's the problem with some scores?" So most of the time when we use survey scores, we just sort of add up the item responses and call it a day. What's wrong with that? And then I get into a couple of research questions I've been looking at, which is, does the scoring model matter if we care about growth? How much does response style, which is sort of like a specific form of self-report bias, how might that impact things, and what can we do about it from a measurement perspective? And then I'll talk about some conclusions and future work. And in the future work, I'm doing a lot that's sort of thinking about how measurement issues impact quasi-experimental program evaluation and experimental program evaluation. So hopefully that opens up some policy conversation as well. So I'll start with this, which is just a quick quote from Jessica Flake, who's a friend of mine. And she says, a high-powered, perfectly parsimonious statistical model cannot save us from poor measurement. And I like this quote for a lot of reasons. One is that I think we all sort of know that we have these measures, we measure things with error, measurement error is a problem, it attenuates the things we care about. But this says, I think even more fundamentally, that if we get the measurement wrong, there's a bigger problem here. There's something fundamental that we need to be worrying about. And I'll just provide hopefully the slides get shared around, but she has a really great site called Measurement Matters. And one of the reasons to give this talk in a policy context, maybe it's obvious to everyone why it's relevant, but there's just been more and more work done in economics, in policy, thinking about survey scores and some of the things we measure with survey scores as the outcome. So as an example, John Pepe did this study where he looked at how these proficiency bands affected college aspirations. So if you're deemed proficient or basic or below basic, how much does that affect your desire and aspiration to go to college, which involved survey scores. A lot of the work by Susanna Loeb and Marty West has been looking at this too with core districts where they're looking at social emotional learning and trying to understand things like school contributions to social emotional learning, you know, returns on investment for these kinds of measures. So all survey based. And another related example is Blazer and Kraft's work looking at teacher contributions to social emotional learning. So if we care about these outcomes for students other than just achievement, and we want to know how teachers or schools or what have you are contributing to them, that's an increasingly big policy focus these days. So I'll go through this background section, and for some of you who do structural equation modeling, measurement modeling, this will be a lot of review, but it's really just kind of to level set. So when we move into the growth modeling piece of this, we're all on the same page. And so the background is really what's the problem with the sum score? You know, most of the time when we score a survey, if you take, you know, 5 questions, they're all on a Likert scale, you could just take the average of those Likert responses, use that as your score and call it a day, right? You could just basically sum up the scores from your items and that could be your score. So what's wrong with doing that? So I'll start with this little puzzle really quickly. So here are 2 tests. We have 3 people taking the test along the rows, and then each column is a different time they took the test. Now let's just assume in this hypothetical world that people don't get tired. They take the test right in a row. They don't get tired and fatigued. They don't learn about the test and get better at taking them. So the question is, if you cared about your score and you wanted a good score from your test, which of these 2 tests would you pick? So I'll give people just 10 seconds, 15 seconds to think about it. All right, so let's do a quick show of hands, and if you haven't figured it out, that's fine. But how many people would want test number 1? Say a smattering of hands. How many people would want test number 2? Okay, smattering. That's good. There's a little division here, which is good. So one way to think about this is if you look at these tests and you look at the average score that each person got, and then you look at the standard deviation of the scores. So what we're seeing here is for the first test, people are not bouncing around a lot in terms of their scores. They're kind of locked in at what their score is. There isn't a lot of within-person variation. But then there's quite a bit of between-person variation. So if you think about what you might ideally want, you might ideally want like all of these scores to be exactly the same. Like if I took this test over and over and it was really measuring what I know and can do, I would want those scores to be the same every single time. And I would want that to be the case because there are real differences between people, not because everybody got them all wrong, say, or everybody got them all right. So there's this idea of how variable is this within persons and how variable is it between persons. And so we can be a little more formal about this. And what we can say is, like, in an ideal world, what we want is for our observed score to match this like true score, this latent variable, this thing we can't see. So for something like, let's use an example of a student's self-efficacy. Like if we gave students a self-efficacy survey and scored that survey, just like totaled up their item responses on the Likert scale, we would want that to equal their true self-efficacy. But what we all know is that what we actually have is this. So we have an observed score, which equals their actual true score, their true self-efficacy plus some error. We can't measure things perfectly. So just one more way to think about all of this is we talk a lot about reliability. This goes back to sort of the test scores that I was mentioning. But you can think about reliability as how much of the variability in your score is about these true differences versus the error that you're getting. So another way to say that is, what's the ratio of the variance that's between persons versus within person? So how much consistency, if you took a test over and over and over again, is there in your scores? That's really what reliability is all about. So what are the effects of this? I think we all kind of know that if you have measurement error, it impacts estimates, and it impacts policy relevant estimates in quite a lot of ways. One of the biggest ones is if we produce effect sizes, it can really lead to an underestimation of the effect size. It can decrease our power to detect differences. So I think that's all stuff that people know by and large. So one more look at all of this. I'm going to show you guys a couple path diagrams. Some of you think in path diagrams all the time. Some of you may have never seen one. So just to sort of orient people, if we have an arrow, that's really saying it's a regression. So if we have an arrow from X to Y, it's like saying we're regressing Y on X. If we have a latent variable, that's the thing we can't see, and that's what we care about. If we have the rectangle, that's the thing that we actually do see, your observed score. And that's what we're working with most of the time. So here's a path diagram that basically says, when we looked at this example of we took a test a bunch of times and how reliable is it, we have this latent variable that we want to estimate, this eta. This is your, say, again, your true achievement. We gave you these Y1, Y2, Y3, Y4, Y5, or 5 math tests. What we really want to know is your true math achievement. That's that eta. And then we have these 5 math scores. And so some of this is just error, some of it's error, and some of it's what people really know about math. And that's what we're trying to break apart a little bit. So I think, long story short, at this point, we sort of know we oftentimes measure things, we measure them with error. Error is a problem because some of the things we care about aren't estimated quite as well. But I think one of the biggest things to think about is that this isn't really sort of where the measurement story ends. So here's another example of a test. We have test 1 and test 2. And this time we have 3 people taking it, but it's just a single test. And we have the test questions ordered from easiest to most difficult. So question 1 is the easiest. Question 10 is the most difficult. And so one of the things that you might notice, I won't let it percolate and quiz you on it again, but in one case, we have these values skipping all over the place. So this person is getting some easy items right, some wrong, some middle questions right, some wrong, some hard ones right, some wrong. And that's kind of a problem, right? Like if they're really good on the subject, we'd want them to just get all of them right. Or if they're struggling, they'd get the early easy ones right and some of the others wrong. So we can sort of account for these things when we actually think about measuring something. And now we've added this little beta I, and what that is maybe for items or a rater that basically just says like the item difficulty is different, or each rater, like maybe you get a grumpy rater who comes in to evaluate your classroom. They always rate everybody low. Or you get someone who is just cheerful and doesn't want to offend everybody and always gives a good score. We can account for that in some way here. And so here's a sort of a classic example of this. So to make it really concrete, like let's say you're interested in measuring depression. So you might have 2 items measuring depression. One is a question, how many times a week do you feel sad, right? Another question, very different question, is have you considered committing suicide in the last week? Like radically different questions. But without that little beta I in there, we would assume that these 2 items fall at the same point on the depression scale. We'd assume that these 2 radically different questions are sort of giving us the same sorts of information on the scale. And lest anybody think that this is just a toy example that I came up with, there's a lot of research showing that there are about 280 different depression scales that people have used over the last century. And depression has one of the lowest inter-rater reliabilities of all mental disorders. So basically it says the measurement is very poor. And part of the reason the measurement is poor is because we're ignoring some of these things. So we've done this and we've said, well, maybe the items are more difficult, but why stop there? Maybe what we really want is this additional term, this lambda sub I, which basically means, what we've assumed until now is that is a 1. So as your true self-efficacy, say, goes up by a unit, your observed self-efficacy goes up by a unit. But maybe that's not the case. Maybe what happens is for every unit your real self-efficacy goes up, your observed self-efficacy only goes up by like 0.8 or 0.7. So this is almost like saying there's a different reliability for every item or for every rater. And so one way to think about this is, let's say we have trained observers go into a classroom and rate teachers on the basis of how well they teach math. One is trained really well though, and one isn't. The well-trained rater is really highly reliable. The other one is not so reliable. Their scores bounce around all over the place in ways that have nothing to do with how good the instruction is. And so basically, without including this additional term, we assume that they're the same. We assume that the reliability of all these raters is exactly the same. So then, to go back to this idea, one of the models we built is we started with this, which is just a whole bunch of individual test scores. But we're able to fit these models where we account for the differences in the difficulty of the items, for the difference in the reliability of the raters, for all of these things, for the measurement error that we were worrying about to begin with. And now we come back to this idea of, so what's the problem with a sum score? Well, as it turns out, when you just take any test, and let's say you have a math test, and it's just, you have a bunch of, did you get the question right? Did you get the question wrong? You could produce a score by just tallying those zeros and ones. But that's going to assume all of the things that we just said are kind of dangerous assumptions. So we're going to assume that every item is equally difficult. We're going to assume that every item is equally reliable. We're going to assume that the error associated with any item is consistent no matter what. So when we use these sum scores, we're making these really large assumptions about what we're measuring and what we care about, beyond just that we have some measurement error. We can't measure anything perfectly and we should care about that. There are much more fundamental questions at play. So just as one more example of how all this kind of plays out is, so let's say we have 2 students, they give 6 item responses on a survey. One student gives, out of 1 through 6, they give some 5s, 6s, and 4s. Student B bounces around a little bit more, 2, 3s, and 1s. Both of them have the same sum score. So if we just totaled their scores, they have the same score. If we account for all those assumptions that I was just mentioning, student B scored poorly on the items that actually really meaningfully measure what we care about. And so their latent variable score would be about negative 0.88. And what that means is that's in standard deviations. So, and it's sort of normalized. So that says that this person is well below average. Whereas student A's score is 1.43 standard deviations. So very, very different scores. And again, this is not just a toy example. This is a measure that is used all the time in psychology and behavioral economics. So some real problems that arise. And unsurprisingly, if you just use the sum score, it's been shown to affect reliability, classification of students, diagnosis of psychological conditions, evidence to support uses of measures, and treatment effects. So I would imagine that pretty much anything or that anybody in this room cares about as social scientists is probably biased by some of these issues, if not accounted for. And then so one more, this is just kind of to pick on psychology, but there's similar work saying the same in economics and other fields, is that in this review of about 35 empirical articles, there are 433 scales, about half contained no information, no reference to a validity study. And a validity study would basically be saying, like, you should trust these measures. We've accounted for the fact that raters are differently reliable or that items are more or less hard. We've accounted for all those things. And in some cases, there's just like no measurement information provided whatsoever. So I would argue pretty big problems and problems that are generally just glossed over across the board in a bunch of major disciplines. So I'm going to actually now finally, after maybe being a little pedantic about all this, get around to my own research. But any questions for, yeah. Go ahead.
So just asking for a friend. Should we do you think the level of this problem, you view this as more or less of a problem if the left-hand side outcome measure versus, say, a right-hand side measure where we're using sum scores as a source of measure for heterogeneity in treatment?
Yeah, I mean, it can be a problem both, for sure, for different reasons. I mean, I would say that if this is your outcome variable, I would for sure worry about it, because in some cases, it's like, you know, for example, you might be looking for a treatment effect, but the real question is like, a treatment effect on what? Like, what are we actually measuring? So if you can't even drill down in that way, then I think that that gets especially problematic. But you know, if you throw a predictor in a model and the model is picking up a whole bunch of noise, or a whole bunch of like it's just conflating differences in raters or that kind of thing, it could certainly provide misleading guidance too. So that's kind of hand wavy, but it's like I don't think they're just different problems. If I were forced to choose, I would probably say worry a little bit more about the dependent variable, but there's a lot of good evidence on the other side of things too. Any other questions before I plow into some of my own work? Yeah.
So it seems like you're mostly looking at internal consistency of and other sources,
Mm-hmm.
for example.
Mm-hmm.
Maybe you're going to get to that. But I'm wondering about the distinction between scale and
Mm-hmm.
some of the constructs, like depression, we really don't think of distinctions as these kind of uniform samples of construct, but rather indicators that naturally vary across people. Not everybody is suicidal.
Mm-hmm. But
People can be equally depressed, but just not suicidal.
Yeah.
So we have to really call it an index rather than a scale. So I'm just wondering what that distinction, how that applies to the argument.
Yeah. So I mean, there are different ways to think about it. One is like if you think that there are very particular behaviors that you can observe and that are very strong indicators of something, then you might think about that as a slightly different way than if you're thinking about something as a real item in a survey, say. But I think, and maybe you have a different perspective on all of this, but to me, sort of the bigger question is, a lot of times people also don't even think about the fact of, is this unidimensional thing, right? Is depression this singular thing? Or put even more simply, should we just have one depression score, or should we have a bunch of depression scores? You know, are they correlated or aren't they? Like, all of those things are relevant, and almost all of them get glossed over. So a lot of times, actually, even just the basic question of like, is depression or anxiety or self-efficacy, like, are any of these things just you know, one thing we can measure? Are they a lot? That gets glossed over in a lot of the studies. So I don't know if that totally speaks to your question, but okay, that sounds good. Yeah.
So I was interested and surprised the review that you guys do
Mm-hmm.
assessments. Do you have any sense of field assessments that better in qualitative education? I mean, it seems to me like the newer
Yeah, I mean, I think slowly but surely, I think people are starting to care more about these issues, which is definitely heartening. But I mean, there's still a lot of, Let me put it this way. I haven't seen anything that sort of updates and recharacterizes those studies. My gut sense is that things are getting a little bit better, but it's hard to say. And it's for sure it's discipline specific, and there are a lot of quant psych journals where they pay lots of attention to this sort of thing. But yeah, it's really to me more about like on a study by study basis. If you go through, like before anybody uses a measure, you should just think really carefully and intentionally and see what evidence is out there. I think hopefully people are providing validity evidence. But okay, so I'll plow into the next phase, which is, so this has all just been very slow table setting and table stakes. But one of the things I've been interested in is, okay, so what if what you really care about though isn't a single score? What if what you care about is a bunch of scores over time, and what you want to know is about the growth of a student and their self-efficacy, or how much a teacher contributes to self-management, or any of these types of longitudinal questions that people might worry about? And one of the things I think you'll see is that all of the issues we've just talked about get compounded and exacerbated when you're looking at these things over time. I apologize, I guess. I don't know. Has it been happening the whole time where it's sort of blocked up there? Or?
I'm wondering if you click on the I don't know if that's
Up over here. This thing. Well, this will either fix it or guarantee that no one sees the rest of the presentation. So either way, there are pluses and minuses to each. All right, I'm not sure if anybody's technologically savvy and wants to try and help me figure that out. That'd be great, but I don't really know how to get that to be hidden. So let's say, we have longitudinal data, and as it turns out, once again, like the way most people score longitudinal data is just using a sum score. So like almost everything we know about how kids develop is by using these sum scores, which you might imagine is a little problematic. So let's say for a second, the line of research that I've been doing is, let's say for a second, you've like bought my argument, you want to actually account for all of these things. You have to sort of estimate all the parameters in the model. You have to come up with values for each of these things, how reliable the raters are, how difficult the items are. But you have data from a bunch of different years. So how do you do that? How do you estimate these things? So one way to do it is to so just to start, let's say you have data that are longitudinal. So you have kids starting in 5th grade, moving through to 8th. So you can follow individual students over time. What a lot of people end up doing is, even if they fit these fancier models that I've been talking about, they say, well, we took some data in 5th grade. We've got them from a single time point. Let's just like estimate these things, lock them in, move them forward for later time points, and just call it a day. So let's just estimate it at one time point and assume it carries forward. In other cases, people say, well, we sort of buy that there'd be differences in terms of how 5th versus 6th versus 7th versus 8th graders think about these things. So, but we don't have all the data collected yet. So let's just take 5th, 6th, 7th, and 8th graders who are not longitudinal but cross-sectional, so just all from a single year, and score it that way, and assume that the 8th graders now are going to be like the 8th graders later. Then another approach is to actually acknowledge that we have these longitudinal data. We follow kids over time, and maybe that matters. So again, just to get into these path diagrams for a second. So the first one up here is we just say, yeah, we got everything from time 1. We're going to estimate it at time 1, be done. Another approach that people take is, so we've collected all this longitudinal data. Let's just pretend that there are no repeat students in the data set. So I'm in the data set 4 times, but I'm just going to pretend I'm a different person in 5th, 6th, 7th, and 8th grade, and let's score stuff that way and see what happens. And I should say, by the way, that like these, again, these are not just these like hypotheticals I'm making up for fun. These are the common approaches that most people use. And so then what we're examining is, well, what happens if you actually fit a model, this call a multi-dimensional model, but really just a fancy term for, let's acknowledge the fact that we care about our scores at 3 different time points in this example, and that we think that these scores, as you can see by these sort of arrows here, are correlated in some way, right? They're the same person. My score is going to be related to my score at a later time point, at a later time point. Maybe we should factor those into things. And so what we did to examine this question is we basically did a simulation study. And I should mention that this research is done jointly with Megan Kufeld, who's a colleague of mine from NWEA. And so we simulated these true scores, these eta j values. And so we know in advance what true growth is. We know how much kids are growing. And we can try and see, well, let's think about how we score these things and see how good a job we do of actually recovering the true growth of students. And so which scoring approach does the best job of actually getting to real growth? So what we have here are, we simulated a bunch of different conditions, made a bunch of different assumptions, but this is just pulling out one of them to look at. So this is a case where over time kids are growing. We know because we made up the data, you know, totally the puppet master here, that the true slope for kids is about 0.5 standard deviations a year. That was one of the higher conditions, but let's assume they're kind of growing like gangbusters. So this slope mean is basically the estimate of their growth. And what you end up seeing is in the population, it's 0.5. Because we simulated the data, we know the true scores. So we dump those true scores into a model for growth, and the slope, so the rate they're growing is about 0.49. Then if we turn to the observed scores, so we just sum up the scores, we take our average, we do whatever, we don't fit a measurement model. Our estimate of the growth is about half of what it would be if we actually fit a model that accounted for these things. And I think one thing that's sort of surprising about all this too is that if you actually fit, so the next 2 columns here, these columns, are the cases where we fit these measurement models, but we just ignored the fact that there are scores for multiple people over time. And so even when you do that, even when you account for sort of like differences in how hard the rater is, differences in, you know, how difficult the item is, but you just do that at one time point and then forget about the rest, even there, the estimated slopes, so the growth is pretty low. We understate it by about 0.2. So what you care about is how fast kids are growing, you're getting it wrong by quite a bit if you don't pay attention to these things. And as importantly, a lot of times what we might want to know is how variable are these things? Like, are all kids growing the same and consistently? Or are some kids growing a lot? Some kids are growing a little. If we look at the slope variance in the population, it's about 0.08. If we use an observed score or one of these even measurement models that ignores the correlations over time, we're estimating that variance at about half. Whereas we get all the way over to this column, which is the model that accounts for the correlations over time, and we're getting a lot closer to reality. Yeah, oh, sure. Yeah. Two slides, you said?
So I'm just trying to, all right, so, yeah, that one.
Yeah.
So it's correct to understand what those betas there. In first model, you have an intercept of the slope that directly affects the third model at the time point. And the observe the sum score one, intercept and slope are directly on the guide.
Well, so basically what ends up happening is, maybe this is not your question, but we are estimating, we're scoring all of them using an IRT model, and then just pulling out the scores and then putting them into a growth model.
Okay.
Yeah, so we're not, exactly, yeah, sorry, I should have mentioned that. So glossed over it, but we're basically doing a 2-step process here where all of these are like item response theory models. So there are a lot of students from my SEM class here, which is great. So in SEM, we might have fit this all together, just sort of done the growth component and the scoring all together. But here what we're doing is just estimating the scores. Yeah. Okay, so let's look at this visually. So what we see in this upper left-hand corner over there, your left, is we have these slopes. Hopefully you can see them okay. But like we see a lot of variability. Funny, the laser, I don't think the laser pointer shows up on here. But the variability, here are the intercepts. They vary quite a lot in our true scores. The slopes vary quite a lot. If you look at these things, up here, this is the sum score. These are the measurement IRT models that ignore the correlations over time. You can just see that these plots of growth are a lot more muted, whereas they're really much more variable if we pay attention to how we're scoring these things. So then the next thing we did is we decided we wanted to make sure that this wasn't just about how we simulated the data, that we didn't create a world that was really different. And so we do a lot of work with Santa Ana Unified, which is a member of the CORE consortium. They administer these social emotional learning surveys on self-efficacy, growth mindset, and self-management. And so we went through the same exercise again. Here are just plots of the linear trajectories for each of these things. Kind of depressing, but self-efficacy declines steadily as students are in middle school. So actually, this is a totally separate area of investigation, but like just as their math scores are going up, their math self-efficacy is going down. I'll let some of the psychologists in the room puzzle through that a little bit. But so we have growth trajectories for these real scores. And once again, the difference here is clearly we don't know what reality is. We don't have our true scores here, but generally what we see is the patterns are pretty consistent. So for example, the sum scores actually do a little bit better here. But for the slope, this model where we pay attention to the correlations is the highest of the bunch. It's lower for these other approaches. So even when we're using real data, what we see tends to hold up. Again, this is a case where actually the slope variance is a little higher for the sum scores. We're still kind of sorting through that, but a lot of the variances when we use these other models is not nearly as high. So long story short, we simulate all the data, but we see very similar things when we use real data from real kids over time. And then the covariances are really different. So the slope intercept, do the kids who start high also grow fast? So the key takeaways here, first, how we estimate these things in our measurement model gets a lot more complicated when we care about growth. Some scores do even worse than at a point in time. So all the issues we mentioned with some scores to begin with get worse. And even the latent variable estimates, we fit these fancy models. If you ignore the fact that we have multiple time points and what you care about is growth, you're probably going to be way off on how much growth is occurring. So let me pause there for a second. Questions on this study before I plow into the next? Oh, good by and large. Yeah. Mm-hmm.
And then when we are thinking longitudinally, are those things varying over time too? So are we allowing items to vary? That's the one that's part of the net. They're just doing the same test. Are you allowing different?
Yeah, no, that makes total sense. And it's actually a great question because it's something I absolutely glossed over, but because it's sort of a subtle distinction. But what we end up doing is you do want those things to be equal over time, because if they're not, then it sort of suggests that the thing you're measuring is changing over time too. And if it's changing over time, what does it even mean to think about growth? if, you know, self-efficacy means different things to fifth graders versus sixth graders versus seventh graders, what are we doing? What are we estimating here? So what we end up doing is constraining all those things to be the same. But even though they're constrained to be the same, and we made sure that that's defensible, the actual estimates of those things will be different than if we just use a single point in time. So the long story short, like those things, the rate or, you know, reliability or difficulty or whatever, those are going to be equal over time. But that does not mean they equal what we would do if we just scored everything based on a single time point. In part because we're accounting for the fact that these scores like are related to each other over time. Yeah, so that's a great question. In fact, one of the things which probably we'll not have time to get to, but I think about that issue specifically of if we suddenly think maybe we're not measuring the construct the same at different time points or across groups, what does that mean for randomized control trials? So that's actually a really prescient question. I thought I saw another hand. Is there someone? Yeah.
I think maybe related to our question, in these previous slides, we're still looking at a sum, like growth on a sum, right? Our growth of that in the
Yeah, so the sum score is basically, you know, that's one of the tricks to it is like a sum score is a sum score is a sum score, right? Like we just can't investigate any of these things if we use a sum score. And so, you know, for every time point, all we're doing is like, you filled out your survey on a piece of paper, you slid me that piece of paper, I'm gonna tally up your score, like how many 4s or 5s you gave, and run with it. So what we're showing is if you get more nuance than that, like you can do a whole heck of a lot better. And not just like if you abandon sum scores and fit an IRT model. Like I think a lot of people generally know, like if you just like, especially on a math test, say, like if you just gave a kid a math test and said, here are a bunch of 0s and 1s for whether you got the items correct or not, and tallied them up, like I think a lot of people would just accept on its face that that's problematic because, you know, like for example, maybe I gave you, if our tests are different, maybe I gave you a lot of items on calculus and someone else was doing fractions, right? Our sum scores wouldn't mean a whole heck of a lot. So I don't think it's surprising to people necessarily that doing that and then trying to figure out growth is problematic, but some of the addition here is even if you fit an item response theory IRT model, but do it in a way that isn't especially thoughtful in this longitudinal context, you are still going to drastically understate growth. You're going to fall into all the same issues that you fell into when you were just using a sum score to begin with. All right. Let's see how we're doing on time. We're getting pretty close. So I'll move through this. It's funny. Even having you know, practiced this once, I wasn't sure, like, is this a lot of material or a little material? I think it's a lot of material, but I'll at least give a preview of this third study, and we can talk about it after if people want. But so the third question is, so we've talked about a lot of problems with measurement, but one more might be, what happens if we have response style bias? And response style bias, defined in a very dry way, is a systematic tendency to respond to a range of questionnaire items on some basis other than the specific item content. If you make sense of that, you're smarter than I am. Put more plainly, how much should we worry about self-report bias? So it's like, maybe kids are growing, but maybe kids are growing because when you're in 5th grade, like you really don't want to upset the teacher. So you're going to select your 4s and 5s on your scale a little bit more. But as you get to 8th grade, care just a little bit less, right? You know, hypothetically. And so maybe you're more willing to give 3s and 4s. Like, is that actually what's driving growth? So a lot of my body of work, at least in this area recently, has just been like, if we want to estimate growth with these things, are we even justified in doing this? Or is it all just artifacts of how we measure things? So one example, and what I'll probably do is just focus on this particular example and fly through the others, is to make this concrete. So people talk about, I guess it's hidden up there, I apologize. But something called extreme response style, or ERS. And this is something that occurs if people are more willing, like if you have a Likert scale going from 1 to 5, and you're more willing to use the 1s and the 5s, regardless of where you are on the construct we care about. So regardless of your self-efficacy, regardless of your level of depression, if you as a human being are just more or less likely to use 1s and 5s, how much of that is a problem? How much of that is driving growth? And we'll say there are all kinds of other patterns here, like maybe some people are more likely to just pick the middle category every time, or maybe people are more likely to just pick positive categories. So there are all kinds of different flavors of this. But so one way to think about this is, so let's say you have these two people, they respond to items 1 through 4. This first person, it's a scale of 1 to 5, Likert scale, strongly disagree to strongly agree. And the first person selects a 5, a 4, a 5, and a 1. The next person, a 2, a 3, a 1, and a 2. In terms of their extreme response style, the way you could think about this is the people who picked the 5s and who picked the 1s, we're going to give them a 1 if they did that, and a 0 otherwise. So we're going to code whether they responded in an extreme way. And this person down below, by the same token, even though they're hovering towards the lower end of the scale, they only use the extreme response category once. So we'll give them a score of 1. And as it turns out, that's terribly fuzzy, but what you can do is basically almost think about it as if these are responses to a test. So these 1s and 0s, you can think about it as almost like were you correct or incorrect on a math question, and then produce a score for a person, like how extreme is their response style. And so you get, like I said, it's fuzzy, but so you get basically these two latent variables where one is their actual score on the survey you care about. One is, say, their self-efficacy. The other is how likely they are to use the extremes of the response scale. And so you're kind of netting out this propensity to, just use the survey in a weird way. So I don't know if this helps or hurts, but one way to think about this, probably hurts, but I'm going to talk about it anyway. So one way to think about this is you can think of every category as an individual response to an item. So you get a 0, 1 if you move from a 1 to a 2, a 0, 1 if you move from a 2 to a 3. What you have down here is their true score, and then their probability of picking a response category. So what we see is if you're really low, this is kind of light to see, but if you're really low on, say, self-efficacy, you're very likely to pick this lowest response category. But what we're saying is if you use extreme response style, or it's easier to see the black. So if you're really here there's no extreme response style going on. So if you're really high on this construct, you're very likely to pick the top response category. But let's say you use extreme response styles a lot, independent of your self-efficacy. We're going to say there's still a really high likelihood that you're going to pick the most extreme category wherever you are. So in any event, this is a lot to throw at you, but I think the visual can help sometimes. So there are two questions that are kind of investigated here. I'm doing it in time. One is, does a person's own response style shift over time? So one of the things we were curious about is if you like using the extremes of a scale, do you always do that, or does that change if you're in 6th grade versus 8th grade? And then how does that affect growth? So once again, here we're starting with actual data because there isn't even really enough known about this to simulate the data. We just had to start with real data and kind of go from there. But one of the things you see is this has here for a cohort of students in Santa Ana who began in 5th grade. We followed them over a number of years. We'll ignore the socially desirable responding, but these are the proportion of students who used extreme response styles. And what we see is, for self-management anyway, that goes down steadily. So the number of people using these extreme response styles is a lot higher in 2015 than it is in 2018 as we follow those kids over time. So basically this seems to suggest that maybe people use the scale in a different way over time and we should worry about that. So just one more way to look at this is we produce scores for their extreme responding styles, how likely are you to be an extreme responder? And if they weren't shifting at all over time, we'd expect really, these are the correlations in the scores over time. we'd expect perfect consistency, but that's not what we see. What we see is they're really highly correlated, between 5th and 6th grade, but the correlation between 5th and 8th grade is much lower. So that suggests that people are using these extreme response styles differently over time. So with that added wrinkle, we decided to see how that affects growth estimates. And so there's a lot going on in this table, but these are the slope estimates. The very first one is when we just didn't account for the fact that people respond in extreme ways. So the slope there is about 0.11. In some cases, if we accounted for it in different ways, it shifts a little bit, but in some cases, it shifts a lot. So here the slope is almost doubling if you account for how they're using these response scales. So there seems to be a real impact for how we estimate growth. So I'll just kind of glide through this in the interest of time, but we also did a simulation study, and we actually saw things that were a little less pronounced, even when we basically tried to build a model that would break things. So like, what if you have a lot of really extreme responding, what happens? And even in those cases, we didn't see huge differences in the slope estimates. And in fact, when we accounted for extreme responses, some of the times it actually muted some of the differences in growth we saw in terms of the just variability in the growth. So big takeaways here, response style can affect growth, but it depends on what we're measuring, the type of response style bias. So, whether you're using the middle category versus the extremes versus whatever. And the assumptions we make about whether response styles vary over time. So are you consistent or are you not? And there's more work to be done. Okay, so we're pretty close to time. But what I'll do really quickly, especially since we got a lot of policy folks, just highlight some of the work I've been doing that's in a similar vein, but is more about sort of experimental and quasi-experimental work. So again, we should care about measurement. And this is just one of my big takeaways is if I think about how much time, including myself, getting pulled into rooms I've spent sort of like fretting about power and internal validity and standard errors and clustering and all these like very relevant and important questions, then to be hand-wavy about the measurement piece seems problematic. So one of the things I've been looking at is how much does this impact, again, the title is hidden, so that just adds to the mystique, I suppose. But if you're using, apologies about that. If you're using sum scores, how much does that affect estimates in a regression discontinuity? And it turns out it can impact things quite a bit. And so, we've all seen these RD models, and they're pretty familiar. I won't walk through the details, but turns out you can do this, a whole RD estimate as a structural equation model. And the question is, do we use this actual true score estimate, or do we just sum up these observed item responses and use that as our dependent variable? And it turns out that matters quite a bit. The other thing is if we're in a randomized control trial and we have what is technically called failures of measurement invariance, but that's basically exactly Veronica's point. One of the big things that we assume when we fit these things is that all of these things, the item difficulties, the reliability, are the same for different types of students. But what happens if by student subgroup they're different? Or one of the things I'm looking at is, let's say maybe you're in a treatment group. The treatment group is about growth mindset. Maybe you come to understand growth mindset differently if you're exposed to a treatment on growth mindset. If you're measuring something differently, then that can really radically alter some of your estimates. And so what we have here, these are plots from a bunch of simulations where the true treatment effect is 0.3. And this is the case where there's no problem with differences across groups. So we're recovering it perfectly. But then we start to say, well, maybe the difficulties are different across groups. Maybe the reliabilities are different. And what we see is we can pretty significantly overstate or understate the treatment effect if we don't account for some of these things. So, I even got animation for my contact information. But hopefully that gives you at least a broad perspective on some of the work that I do and some of the ways I think about things. I'm excited to chat about this more in the next, half an hour-ish, or, anytime thereafter. I'm hoping this opens up opportunities to think about shared work. So thank you very much for listening. Yeah.
So if we're interested in taking these not response time and go from, you maybe suggested that response time change over time. I think I saw a table you're going through there that looked at the types of growth that have estimates for new specified environment.
Yeah.
And so what's your recommendation? Would that empirically follow out?
That it,
Specified as time varying?
well, so it definitely had the biggest impact on growth estimates, unsurprisingly, when you treat it as time varying. And it really, I mean, I guess this isn't overly surprising, but I was a little surprised by just how much it depended on, are we talking about growth mindset or self-efficacy or self-management? And are we talking about using the extremes of the response scale versus the middle category versus whatever? It really, like whether it varied over time really depended on all those things. So in some ways, yeah, which is exactly what all of you wanted to hear, is that there are no answers and you're in a lot of trouble. Always good news. But I mean, so this is why there's a lot more work to be done, but our main recommendation at this point is just kind of look empirically. Like if you even just sort of produce those categories like we did, like give your survey respondents ones if they selected the extremes and 0 otherwise, and just like look descriptively to see how much these things might be changing. And then you can kind of go from there. But yeah, it's still a pretty muddy picture. Yeah.
I like that you said for items that are social anxiety or some other types of approach generally for the coding it and ones for the ones that realize or use this in your
Yeah, so it differs a little bit. And it's funny because there's so many different definitions of these things. But, if it's like socially desirable, I think the way people code that is it's 5, categories. You select categories 4 and 5, assuming they're the highest. That's how you would treat it as opposed to, 1 and 5 for the extremes. Some people even have coded it so that it's just the 4th response category, because it's like you're really middle of the road, but you don't want to seem middle of the road. You want to seem agreeable, so you select 4 instead of 3, right? I mean, there's an interesting psychological component to all this. But like for any combination of different responses where you worry that it's people just using patterns that have nothing to do with the thing you care about, you could code it as such and see what's happening. Yeah.
Wasn't sure I wanted to ask you this question because I'm not sure what the answer to it. So you got to it in the last 2 slides in the RCT. That is, we just been extensive RCT about some behavior mechanism. We had it from parents, we had it from teachers, we had it from kids, but basic observations. And as you were going through it, and you began to learn a lot, I was comforting myself by saying these problems are going to be less in RCTs than they would in just quantitative behavior. And then you kind of said, but
yeah,
you can run on the problems you would run into if you have RCTs in the absence of missing data and non-compliance and things like that. You got a perfect RCT. The degrees of which you're going to run into these kind of problems to reduce those, and we're just doing
like any good answer to this sort of question. I mean, it depends a little bit, but I mean, one way to think about it is, so I was looking at 2 cases. Like if you think that there is bias in terms of how the measure works or real issues with reliability between the control and treatment group, that should be cause for concern. Like if you think the control and treatment group are interpreting your measure differently, well, so that's the trick, is like that would have to be some slightly more convoluted scenario where getting assigned induces you to respond differently. And that's why I sort of thought about the example I did is like, maybe if you're going through this intervention where you come to understand what growth mindset is, like maybe you think about growth mindset differently. Maybe you rank yourself differently, lower than you might now that you know what it is, or higher. So that generally isn't a huge concern. But if it's really, you're worried about, like, well, maybe we're measuring this thing differently across subgroups. In some ways, you know, the randomized control trial will wash out some of that because you should get equal proportions of subgroups across control and treatment. That's true if what you're talking about is something like the item difficulty. But if the reliability is really different between the two groups, that actually means like the slope, the relationship between like what a 1 unit change in your true score means relative to your observed score is different. And so there, the bias is more, a little more minimal, but you can still get bias treatment effect estimates. So most of what I've been looking at is this case of like differences across groups. If you've kicked the tires, you're not overly worried about that, then you know, the randomization definitely helps, but it's definitely not sufficient to just cancel out all this stuff.
Let me give you one example. So we asked parents and teachers the same set of items about special education.
Mhm.
And the effect sizes we measured on the after school program. Teachers rating the kids as they see them in the classroom. We got strong effects.
Mm-hmm.
Parents, we got no effects.
Yeah. Mm-hmm.
But we sort of attributed that to the fact parents have bias. Parents don't have kids measure them against their time,
Mm-hmm.
things like that. And I'm also wondering whether there's something true in different nursings about parents raising their kids versus teachers raising kids in the classroom.
Yeah, I mean, there definitely could be, and there are ways to look at that empirically. And there are even ways to, well, assuming that they're sort of construing what you're measuring the same way, these two groups. Like they're even, this is why it's worth getting into, you know, the scoring model isn't just about subtracting off measurement error, clearly. Like another scoring model is to say, like, we're going to produce one score that's like the shared variance between, say, parents and teachers, and use that. Like if we really think this is measuring the same thing and they're just interpreting it differently, like we should be able to score it accordingly. But yeah, I mean, these issues can crop up in lots of different ways.
Yeah, so this is a great presentation. Tim and I in our group have been doing a lot of work on mischievous adolescent responders. Now, you look at kids who are responding to too high or too low, but I think there's an interesting group of kids who choose to present themselves in the extreme, not socially desirable, but undesirable.
Yeah.
Chantal Fan with the National Adolescent Longitudinal Study found this great example of that policy component. They found that the kids who were adopted in this National Adolescent Survey had higher drug use and higher fights and all kinds of high-risk behaviors. And this led to this notion that adopted kids are seriously at risk. And there may be some reason to think they are. But it turns out Fan found that many of these kids who said that they were adopted were lying. Because a national survey also did parent interviews, and they asked the parents, and they brought together the data together, and found out a lot of kids said that they were adopted who weren't. A lot of kids claimed that they were amputees who weren't. A lot of kids claimed a lot of things that they weren't. And those same kids have a tendency to endorse high-risk behaviors across the board.
Mm-hmm.
I'm adopted. I'm a drug user, you know, I'm being bullied in school, I carry a gun to school. And since then, we found this in a number of surveys that a small percentage of kids will pick the most outlandish answer. And so we have started correcting for that. We've got a number of different procedures that we use. Mm-hmm. One is we ask kids, are you telling the truth?
Yeah.
And it turns out a certain number of kids will say, no, I'm not telling the truth. And when you look at those kids, yeah, those kids are endorsing these extreme responses. And when we and they inflate the correlations between risk behaviors and troubled conditions. So when we take them out, the correlations go way down.
Yeah.
It certainly has an impact on substance questions. So
Yeah.
we routinely do this with our statewide school climate surveys. We routinely screen them. We find much lower rates of risk behavior. A lot of these kids claim that they're suicidal, but they also tell you the line. And so we've studied them longitudinally too, and I can tell you we follow them in middle school. Their tendency to be invalid responders. That changes. Anyway, so I'll tell you about this time.
Yeah, I appreciate that. It'd be fun to talk more. So I don't know a lot about that work, but I collaborate every once in a while with Joe Simpian Robinson, and so I don't know how much you've seen his stuff on this, but yeah. So he kind of put it on my radar, and I mean, I think it's a great example.
He's got a different technique for detecting it. There's different techniques to detect the variance and how they answer. And certain questions are really unusual questions, but they all point to the same concern.
Yeah. And as an aside, I mean, one of the other big areas of research I do is to try and detect test and survey disengagement. So like, how do you tell if a kid is checking out in the middle of a test or a survey? So there are lots of issues and ways of detecting. But,
Yeah, so first of all, thanks. This was helpful, even at my level of understanding of this stuff. Also, more than mildly depressing. So I guess it's an opportunity to go back and republish about 10 years worth of work. Accounting for
Yeah.
So I'm sort of down on the third order, trying to figure out what the reasons for not doing this might be. And from a policy perspective, I'm sort of wondering about the issue you mentioned. We worry a lot about validity and other things. We worry less about this. But one of the things, especially when some of these measures end up getting used in sort of high stakes ways, in policy interventions, is that transparency ends up turning out to be sort of an important value. That if people don't understand what the measure is and can easily interpret their behavior and connect it to the outcomes. So I'm wondering how you think about that in this context, because this isn't exactly transparent, I think, in many ways of taking the data that we're thinking about observing teachers' behavior. And I go in and I observe a teacher on 9 different dimensions, and I give that teacher a score. I think the suggestion here is that it isn't just let's average those scores, because there are a whole bunch of grader and other things that are at play.
Yeah.
But doing that then, sort of both for the principal, who might have been the grader, and the teacher, sort of creates this, the tape might be too strong, but non-transparent connection between what occurred and what you're telling.
Yeah, and this is definitely something that I lose sleep over a little bit. Literally, yeah, I think literally. Every once in a while, who knows? I sleep pretty well, but it's something I definitely think about a lot, because, so as an example, I just got back from this grant convening where we're working to develop measures of effectiveness for research practice partnerships. And what people are proposing are like these multi-dimensional hierarchical models, which you can fit in an IRT framework just fine, but are you really going to go out and ask, the Chicago Consortium every time they want to produce a score for a teacher to like fit one of these models? Like, this is not going to happen. And so I think a lot of it is just doing due diligence. And like, there's a lot of research actually that says there's some cases where you use a sum score and it works great. Like in some cases it actually outperforms some of these fancy models in the right conditions. And so like, I think that's what we should all be rooting for. It's just like, at least when, we're publishing on measures or, so a couple of scenarios. If we're publishing like a new measure, like comparing those two things would be really useful. Normally people just do one or the other and call it a day. The other that I think you mentioned is really high stakes decisions. So that's where it worries me, because like what you saw in a lot of these cases is like we understated the growth by quite a bit, but we still show that there's growth happening. It was statistically significant growth. So it's like, if you're a teacher just interpreting a measure, like maybe all you need to know is that some growth is happening, and that's good enough. If what we're doing is actually, quantifying how good a school is, that, gain or growth matters a whole lot more. So, but I think the biggest thing is just it should be transparent. We should make these scores as usable as possible. But before we go out and put them into the world, make sure that's justified. Yeah.
Looking at a lot of those, so I don't really do any work with circular measures. I'm
Mhm.
kind of thinking secondary data analysis. What are the measures that I use that are similar to mine? There are a lot of mechanical issues that are being tested. So one of the things that came to mind for me is like GPA and high school GPA.
Mhm.
We're using it as a proxy for the state measure. You get this like index measure of their GPA of 4 years, but it is.
Mhm.
And now I'm trying to think like, does it map mechanically that say like the GPA is kind of similar to the index score that you get at the survey, and then each class that the student is taking so much one item in the test that results in the final GPA.
Mhm.
And then to the extent that like we might have data that rather than just taking that index GPA score, we can do some of the adjustments when we see their individual class grades.
Mhm.
Is that the kind of thing we should be thinking about? Or not just in this context, but more broadly with measurement or control variables, output variables, you know,
Yeah, it does. And yeah, that's a really good question and a hard one, because, you know, being thoughtful about every piece of measurement you do, like there's an argument to be made for that clearly, but it's also like, you know, if you have 12 predictors in your model, like, am I really going to expect everybody to go fit an IRT model to figure this out? You know, no. And the nice part about something like GPA is I think there's already some pretty good evidence that it correlates with long-term things that we care about. So there's some sort of, I don't know if I'd exactly call it validity evidence for that use. But there are a lot of good options you have. So one might be, this isn't totally germane to the GPA example, but for example, let's say you have 3 achievement tests for a kid, like you have ACT, SAT, and something else. You could fit one of these models, or instead of just using those scores, you could come up with a single score. And that might be a little more justifiable. So yeah, I mean, every researcher I guess has to just ask at the end of the day, is the juice worth the squeeze? Is that the right way to say it? Yeah. Did I get it backwards? So I had to think about that for a second. Yeah, it's worth being nuanced about it, but you know, especially if you're using a measure that everybody in the whole world has used for ages, probably in better shape.
MRA is like super high.
Yeah. Yeah.
Do you have the class?
Yeah. I was telling my wife about this presentation, and she's calling it my "Be Afraid" talk. So that's like, for the record, I don't mean it to be that way, because the really nice part about this is, like, yeah, there's a lot that can go wrong, but like, if you think about measurement as one part of internal validity, like there's always a lot that can go wrong. So it's really just about being as thoughtful as you can, doing your due diligence. And the nice part is there are a lot of models now where if you're purely doing this in a research publishing context, there are a lot of models you can fit now to account for some of these things if you worry about them. You just have to sort of take that first step and think about doing it. Other questions? Have I scared people sufficiently, or? Great. Well, I will say, unless there are more questions, as maybe a parting comment, you know, always happy to talk about these things. I think there are a lot of cool applications of these measurement models that are like really relevant to the types of work that people are doing around here. So if I can be helpful as people think through those questions, feel free to knock on my door. Thank you.